Bon, bonsoir à tous. So sorry I will present in English because my French is not as nice to present as, well, at least I don't feel confident enough to present in French. So, mais après vous pouvez demander vos questions en français. Bon, today I'm going to talk about chaos engineering. So who of you already have heard about chaos engineering in the room? Okay. So not so many. So this is good because it's something new that I'm going to present today. So chaos engineering, behind that is the idea of having of experimenting on distributed systems to verify its ability to withstand turbulent conditions in production. Well, this is the definition of principles of chaos.org. It's, yeah, I think not very clear, but during the talk I'm going to explain that to you. Okay, so to start, let's start with the most important thing. Let's start with me. So I'm Eric, I'm from Cologne, Germany, now since 4.5 years in the south of France, in Aix-en-Provence. Started 10 years ago working in QA, quality assurance, then I went to research and development, and now since 2 years I'm working for the innovation labs for our CTO in our company called Gemalto. So we are the guys producing SIM cards, passports, every kind of IT security solutions. And well, I'm working on several disciplines like cloud, security, DevOps, serverless, and also chaos engineering. And we are analyzing how we can use these technologies to make the life of our employees in Gemalto, of our R&D, of our operations better, but also how can we ensure better customer experience by using better technologies. So, and this is why I'm working on how can we bring chaos to Gemalto, and tonight I'm going to explain you what we found out so far about that. To start with chaos engineering, I would like to start with a tweet. Okay, I think this is pretty fitting. So there's this QA engineer. He walks into a bar and he orders a beer. He orders 0 beers, he orders 99 million beers, he orders a lizard, -1 beers. So he's trying everything. What he's doing, he's testing. Okay, so you're testing knowns. What does that mean? You're validating that for a given input, you have your expected output. Okay, but let's see how the story continues. Because now the first wheel customer comes into that bar and the customer asks where the bathroom is. And then suddenly the bar bursts into flames and kills everyone. So what happened here? Chaos engineering happened. So I would like to visualize that a bit further. Let's imagine we have a microservice-based architecture. We have a client service and we have a bartender service. Okay? In the first use case, the client just asks the bartender service, hey, do I have a beer? And the bartender replies, yeah, sure. In the second use case, the client asks the bartender, hey, where's the bathroom? So there is a dependency between the services, and the bartender asks the bathroom, hey, are you available? Something goes wrong, and the bathroom just replies with, I like pizza. And the bartender has absolutely no clue how to interpret that response. And at the end, this escalated a bit quickly. So that's the idea behind chaos engineering. But why is this important and why is it popping up right now? There are 3 important transitions that we are going through at the moment. The first transition is the move towards the cloud. No one is deploying anymore on-premise. Everyone is going to Amazon, to Google, to Azure. So we have the cloud. Why is this important? I will explain later. The second important step is we are going towards microservice-based architecture, away from our monoliths. And the third part is we are going to DevOps. So we are not developing anymore in V-model or waterfall. We are going towards Agile, we are going to CI/CD, and we are applying DevOps principles. So for the first part, for the cloud. I'd like to start with a quote here. This is from Dr. Werner Vogels, who is the CTO of Amazon.com. And he just claims everything fails all the time. And this is essentially what the cloud tries to transmit to you. So if you are aware of Amazon, you have the notion of regions, of availability zones, and at the end, you have SLAs in a given region for certain services. So, for example, you have a 4.9 SLA, a service level agreement that Amazon guarantees you that 99.99% of the time of the year this service is up and running. So you need to work on a solution that is somehow compensating this 0.01% downtime per year. Okay, this is very nice, but when you think about that, is that, okay, you have one service that has this given SLA, this uptime, but when you have several services, the overall uptime of your availability decreases. Okay, this is what you can see here in the chart. So for example, when you have just a 99% uptime and you have 25 services that all have 99% uptime, then at the end your service is just available to 3/4 of a year. Okay, so this is somehow critical, and this is something you have to think about. But this also gives you the idea that you should not design your system to be up and running 4 times per year. You should rather think, how do I react when my system is not available? And how can I maybe degrade my user experience but do not block my service? So this is the first thing why chaos engineering became important on the movement to the cloud, because it helps you applying these fault-tolerant or building fault-tolerant systems in this context that is already designed to fail. The second part, so talking about this is, I would just like to highlight this again a bit more about the notion of availability. So, because what you have is that you're measuring availability with 2 factors. You measure first the mean time between failures, okay, meaning a failure occurred, then everything is okay, and then the failure occurred again. The second measurement is the mean time to recover, meaning how long does it take until I have my system back in its steady state, meaning that it is working properly again. So you have several vectors here that you would like to optimize. So you want that the availability is always going towards 1. Okay, this is what you saw before. You had 99.99, but you ultimately want 1. You want that the mean time between failures goes to infinite, meaning that you will not have any incidents. And you also want that the mean time to recover 0, meaning you want to have a self-healing system that never fails. So because like this, you will have an availability of 1. The principles of chaos engineering support you with that, because you will constantly apply, I would say it's a continuous stress test and disaster recovery scenario that helps you to anticipate issues before they actually arrive in production. Because this is also important when you talk about microservices. You saw before that you had, before we were developing monoliths. Okay, we were developing a front end, a middleware, and we were using a database. Okay, meaning we had 3 components. When you have this formula about connections, you would see that there are 3 connections. It's something that you can manage. You know the impact of the communication and between your services and what happens if something fails. Nowadays we have microservices. We are talking with companies that are having 400, 500, 1,000 microservices in production. You cannot predict all the connections that can happen between the services. So at the end, you do not want to build a disaster recovery for all the services that you put in place, but you want that all your services are self-healing and managing themselves and come back to a state where they are operational. I just want to put this graphic here because I want to visualize that by putting more and more microservices in place, you automatically increase the complexity of your overall system exponentially. And this is why chaos engineering is also important, because it helps you to build this self-sufficient and self-repairing system. And the third part is DevOps. Okay, so I guess you all heard about DevOps and you apply DevOps principles most likely. So where DevOps is, where I think where it's getting its very big strength is when you do things like, for example, A/B testing, canary releases, where you are validating new features for your customer. what you need to have before you apply these principles is you need to have confidence in your system that when you replace one little part of your system, meaning when you continuously upgrade one microservice, you will not break the rest of your system. And also here, the applying chaos engineering principles are important, because only like this you gain confidence in your upgrade, in your deployment scenarios, and like this you can have efficient DevOps. So that's basically what I think are the three important factors of chaos engineering. So for cloud, for microservices, and for DevOps. Now, how can you start? So there's the first and foremost thing that is important is you need to measure everything. So measuring doesn't mean you need to measure, is your machine on or off? You need to measure, this is what we call the 4 golden signals. You need to measure traffic, errors, latency, and saturation. So everything that is going on in the communication between your services, you need to measure, but you also need to measure against your KPIs, meaning what is your product about and how do you measure your customer success? So is it how many insurances you manage to process? Is it how many images you verify? Is it so you have to measure that, and you need to be clear. If I replace version 1 with version 2 of my services, is this going to improve my customer behavior? And then you have a good point to start. Because the second point to start, how you really do chaos engineering, is you're doing game days, meaning you put a lot of people, not a lot, but you put a lot of different profiles in a room. You put operations in a room, you put R&D in a room, you put your product management in a room, and you identify what are your most critical services in your product. And then you build hypotheses. What would you assume when this service fails? How would the rest of your services react? Would your product still be functional? Would it be degraded? You build that hypothesis, and you break the services that are most critical for you. And you verify that this is working, that your hypothesis is working as you would expect it. And if not, you build an action plan and you fix your product until it becomes, in a way, self-sufficient and self-repairing. And then the third part is we need to spread knowledge on the way how we are conducting these experiments. So how do we break systems? Do we introduce latency between our services? Do we inject random error codes? Is it just a simple turning off, turning on? So there are many ways how you can do experiments in either very simple manners or in a very sophisticated way. And for example, there are projects out there like the Chaos Toolkit, Pumbaa. There are a lot of open source products that are now popping up. Gremlin is a product that is like open source, that is a SaaS commercial chaos engineering company. And it's becoming more and more important. So people need to start sharing on how you run experiments. And that's basically what I wanted to say about chaos engineering. I want to close with a quote of Nora Jones. She's a chaos engineer in Netflix. So she did a talk, a very good talk. You can see it on YouTube in the reInvent 2017, Amazon reInvent 2017. Chaos does not cause problems, it reveals them. And I think that's pretty fitting. So that's basically what it is. So now go and spread chaos. Do you have any questions? Avez-vous des questions?
Du coup, si tu introduis, tu disais par exemple des erreurs dans tes communications. Ouais. Ça veut dire que, quelles que soient les communications que tu fasses entre tes serveurs, entre tes propres serveurs, tu rechecks tout 2 fois. C'est-à-dire qu'à l'envoi, tu vas entre tes nouveaux services, tu vas checker, il envoie le bon code, et au récipient, tu vas checker aussi s'il va réceptionner le bon code. Donc tu dupliques du travail du computation time. Alors certes, ça permet de pas fail s'il y a un problème, s'il y a eu un problème produit, mais par contre, ça refait du travail. Est-ce que ça vaut toujours le coup?
Je ne sais pas si j'ai bien compris, mais en tout cas, je pense que ça ne refait pas le travail. Mais ce que tu dois voir, c'est normalement, si tu as la communication entre le service, normalement, ce que tu veux vérifier avec le chaos engineering, c'est s'il y a quelque chose que tu n'as pas prévu arrive, ton système ne va pas tomber, comme dans l'exemple avec le bar. Donc, tu peux simuler tous les cas, par exemple, si tu fais du phasing, si tu implémentes des tests unitaires, mais il y a toujours des cas que tu n'as pas vraiment prévus. Donc, tu sais qu'il y a quelques vecteurs que tu peux optimiser, comme par exemple le réseau, la communication entre le service. Donc, tu sais qu'il y a peut-être quelque chose que tu n'as pas testé. Donc, tu laisses un système automatisé jouer ces expériments et tu vas peut-être trouver quelque chose que tu n'as pas prévu et que tu n'as pas testé. Donc, c'est pas vraiment quelque chose qui tu as déjà fait. Donc, tu doubles pas le travail, si j'ai bien compris ta question.
Et en fait, le chaos engineering, c'est plus une philosophie de travail, c'est-à-dire que là toi, si j'ai bien compris, vous faites ça au niveau informatique, c'est ça. Mais en fait, et puis pour des grosses entreprises, mais en fait, c'est applicable aussi à des petites entreprises, dans le sens où, en fait, ce que tu mets, c'est, si j'ai bien compris, c'est de mettre en défaut, en fait, chaque intervenant et chaque service de ton entreprise pour voir comment l'autre réagit et du coup voir quel impact ça a négatif dans ton entreprise pour mettre en fait en place des plans d'action pour en fait préparer à réagir. Genre en cas, je sais pas, si on est une entreprise de 4, le mec qui est en charge de la com chez moi, demain on va simuler qu'il est malade, qu'est-ce que ça impacte dans ma journée et comment on va réagir pour essayer d'être réactif justement sur ce type de situation.
En fait, c'est une bonne comparaison, exactement. C'est si tu as un impact que tu n'as pas prévu.
Oui, d'accord. Et du coup, toi, ton travail est plus spécifique sur la partie informatique. C'est ça? Ou alors, est-ce que aussi tu interviens en tant que... Est-ce que tu identifies ton boulot, est-ce que c'est d'identifier justement tous les intervenants au sein d'un service ou d'une entreprise et après de les mettre en situation critique pour voir un peu comment ils réagissent et leur dire voilà, c'est là-dessus qu'il va falloir que...
En fait, nous, on se focalise vraiment sur l'informatique. Ça, c'est très technique pour nous. Donc, on donne des exemples, on donne comme j'ai mentionné, il y a de projets open source qu'on peut utiliser aussi en interne. On développe un outil qui s'appelle le Chaos Engine qui conduit les expériments pour nous. Donc, c'est vraiment un truc technique, mais je ne dis pas que tu ne peux pas appliquer ce que tu découvres. Oui. Tu sais, par exemple, cette graphique-là, c'est pas du tout technique. Ça, ce que tu vois, c'est la formule pour l'équipe de pizza. Tu sais, c'est le truc de Jeff Bezos qui a dit tu peux pas avoir une équipe avec plus de 8 personnes parce que il y a trop de communication entre les gens. Et ça, c'est une complexité que tu as dans l'informatique, mais si tu as aussi avec les humains, entre les humains. Bon, donc merci pour écouter.
Merci.
Merci.